So for the Module 6 review, one thing to definitely note is when to use your law of sines and when to use your law of cosines. Yes, you will always be using them when you have an oblique triangle, which is the triangle that does not have a right angle. So keep that in mind. No right angles. You have an oblique triangle. So for instance, know what sides and angles have to be given in order to use the law of sines and to use the law of cosines. So for instance, to use the law of cosines, one of the oblique triangles would have to be a side, side, side triangle, meaning I'm given all three sides. One way to kind of remember when to use the law of sines is that you need a corresponding side and angle. So, meaning if you look at example 2, I'm given side A as well as angle A. So I know I can apply the law of cosines. So I'm given a corresponding side and angle. For dot product of vectors, to note the dot product of two vectors is always going to be a scalar value, meaning it's going to just be a number when you're done. It won't be in terms of a vector. You won't have an ijk or anything like that. So for the first example, if I were to find the dot product of v and w given their vectors, I would take the product of the x values, so 3 times 2, and add it to the product of the y values, which is negative 6 times 4, and then add it to the product of the z values, which is 9 times 8. So this would give me 6 plus negative 24 plus 72. Just do PEMDAS, go from left to right, and you should get a total of 54. That is your dot product of v and w. For the second problem, you are given a corresponding side and angle. So as we noted earlier, you can use the law of sines, which in this case, since we're applying a and b, a over sine of a equals b over sine of b. Now, some of you flip the fraction, meaning you have sine of a over a equals sine of b over b, which is perfectly fine. It's the same thing. I'm going to use it this way, and then I'm going to replace the variables with the values given. Oops. So from here, instead of b, it'll be 12 over sine of the angle b. So in this case, I'm only looking for the sine of b. Now, two fractions equal to each other is a proportion, so I can solve it as such, meaning I'm going to cross multiply. So 22 times sine of b equals 12 times sine of 42. Now, I almost have b by itself, so first I'm going to get rid of what sine of b is being multiplied by, and that's 22. I'm going to divide 22 on both sides. Whatever I do to one side, I do to the other. So, very important here. I have sine of b equals 12 times sine of 42 divided by 22. You'll put this in the calculator, but please make sure when you are calculating this, you press equals after 12 times sine of 42. Press equals after the numerator and then divide that value by 22. You should get something along the lines of 0.3649803. So something along the lines of 0.3649803. You can keep that value in the calculator. You don't actually have to clear it or anything, but this is as much room as I have. So now I'm almost there. I just need to get b by itself. How do I get rid of sine though? So when you're solving for an angle in the law of sines and you have to get rid of sine, to get rid of it, you're going to inverse sine. As long as you keep it balanced, whatever you do to one side, you do to the other. So you're going to inverse sine that value. And that'll give you, I'm out of room, so I'm going to move it up here. And that'll give you angle B equals to 21.41 degrees. I hope this helps, guys.